This agent used the same tool 12 times. It wasn't being persistent. My agent called the same API again and again, even though the previous attempt had already failed. Today, we'll reproduce this runaway loop, analyze why these large language models get stuck in local minima, and build a deterministic fingerprint guard to block identical repeat calls. While building an invoicing agent, a validation error on a currency code triggered an infinite loop that quickly burned through my entire API budget. The orchestrator just kept spinning. To see how this happens, we can build a minimal test agent with a mock invoicing tool. If the currency is not USD, it returns a clear validation error. When we execute it, the agent enters a runaway state. It repeats the identical call over and over again until hitting the framework's hard recursion limit and crashing with an error. This infinite tool loop is like repeatedly pressing an elevator button because the elevator hasn't arrived yet. With zero feedback showing it registered, you just keep clicking. LLMs exhibit deterministic local minima. When generating the next step from a context history containing an uncorrected failure, the model naturally arrives at the exact same action. To break this loop, we first generate a deterministic signature of every tool call. We do this by sorting the JSON keys and hashing the string. Next, we must classify incoming errors. Transient network issues can be silently retried with backoff, but validation errors must be exposed to the model context to force changes. We introduce a stateful tracker directly into our orchestration engine. This middleware intercepts every incoming tool call and matches its fingerprint against a local state store of scene hashes. If we intercept a duplicate fingerprint, we inject a clear, structured system error. This message warns the model that the action failed and forces it to rewrite its arguments. Rerunning the identical invoicing task with our guard active shows the orchestrator catching the very first duplicate attempt instantly, blocking the network call before it can ever happen. The model processes this explicit duplicate block warning. It dynamically corrects the invalid currency parameter to USD, and the task finishes successfully on the next step. Of course, stateful tracking adds some architectural complexity. You must implement opt-out bypasses for operations that legitimately repeat, like polling a database endpoint for live status updates. That brings us to our core rule for production. An agent needs a definition of progress, not just permission to keep trying.